Hello all. Today we'll try to solve the problem from the lead code. Add two numbers. The problem definition is as such. Therefore, two non-empty linked lists are given as an input. They actually represent a two non-negative number. Okay, and the digits are stored in a reverse order. Therefore, every node in a linked list actually represents one digit, and they represent a number as such. Therefore, if we have a linked list 243, this actually represents the number 342. Therefore, it is stored in the reverse way, so that the units place is the first that is stored, then the tens place, then the hundredth place, in this way. And there are two linked lists that are given like this, and we are supposed to actually add them and return another linked list. Okay, therefore this is the expectation from the problem. Therefore, let's see the function prototype. Right, the function prototype is we are given two linked list, and the structure of the node of the linked list is also given here. And I think we can assume that we will malloc the return linked list and assume that the caller frees it. We can, I think, make a safe assumption of that. Now we understand the problem. Let's copy the prototype into our favorite editor. Let me uncomment the structure definition because we would require that. Yeah. Therefore, we need to traverse both the nodes simultaneously and keep on adding the value, right? And as we add the value, right, we have to also create the resultant linked list, right, and return it eventually. Since we are going to create a linked list here, we need a head pointer to that. Therefore, let's create a variable that we will use to store this head. Okay, and we will call it as a head itself. Right. Therefore, how can we traverse of both linked list? Basically, we have to traverse. This would be our condition, right? While L1 and L2 both nodes are not equal to 0, we can traverse it, right? If they are not null, it means it still has some value, and we can traverse it. Therefore, it's possible that one of the number is shorter while the other one is longer. Then it will come out of the while loop, and we have to still be able to handle it. But let's first write the code for this, and then we'll continue with the other one. Okay. Therefore, each time a node is accessed, we have to actually calculate the sum, right? Therefore, let me create one local variable called as s, or let me call it as a sum. Therefore, sum is equal to, right, L1 value plus L2 value, right? Therefore, this is a sum. Therefore, say for example, in the units place, I have say 4 and 8, right? Then L1 of value will be 4 and L2 of value will be 8. When I add 4 and 8, I get a sum of 12. But I have to store only 2 in the units place, and I have to take the 1 to the next digit. Therefore, how do I do that now? Therefore, the simple way of doing it is actually I can have a remainder, right? Let me call this as a remainder, and this is nothing but sum modulo 10, right? If I divide by 10, whatever is left is a remainder, right? In case of 12, we will divide 12 modulo 10 is 2. Therefore, 2 will be stored in the units place. This is exactly what we want. And what we have to carry? We have to carry sum, right? Therefore, sum is sum divided by 10. Right? Therefore this is what has to get carried. In case of our example 12 divided by 10 is 1, and 1 will be carry forwarded. Therefore when the carry forward happens, right, in the next iteration, therefore once this happens, then what I have to do, I have to move L1 equal to L1 of next, right, I have to move to the next node, and L2 is equal to L2 of next, right. Once this is done, in the next iteration we have to take whatever the sum was remaining and we have to add it. Therefore I have to do sum plus, right, I have to add whatever was remaining. And when you have when the while loop is executed the first time, the sum value will be 0 and it's taken care. Okay, there is another important thing we need to do in the while loop is to create our node, right. Therefore we need two things. We have to create a node, right. Let me do a small hash define so that I could reuse this code, right, called as create node. Therefore what should I supply to it? I have to supply h, right. H is of course the head of the node, and I also have to give the node pointer, right. Let's say let's call this as head, and let us call it as a present, right. There is the present node which I want to create, right. Therefore let me also define that here. The present node, and I also have to create a new node out of it, right. Therefore I totally require 3 things here. Therefore what I will do is, first I have to create a new node. New node is equal to, I have to malloc, right. What should I malloc? I should malloc size of struct list node, right. This is what I have to malloc. And once the new node is allocated, right, now I have to insert either to the head node or to the present node, right. The head node would be the first one, the present node would be the present, the last. Okay, I think it should be the last node rather than present, right. I think the last makes the sense, right, because it will keep on moving, but it is the last in the whole of the linked list. That makes a lot of sense. Okay, new node. Therefore I have to either insert it at the head or I have to insert it at the last node. Therefore how do I do that now? The best condition would be that I check if head is equal to null. It means that I have to insert at the head, right. Therefore if this condition is satisfied, then I'll make head equal to new. I'll make then whatever the new got allocated, right, pointing to the head. And I can actually even also make the last also point to the new, because it's the same, right. And I will have, yeah, once the new node is created, I should always have the next pointer pointing to null, because it's a new node, right, it doesn't point anywhere, right. Head is not equal to null, right, in the else condition, then what do I do? Then I know I shouldn't insert at the head, but I have to insert at the last. Therefore what will happen? Last of next is equal to new, right. And last is now, this becomes the last pointer now after this is done. Therefore what I am doing with this hash define, actually I could have written a function also, which would have been much better if you ask me. Yeah, that is fine. The same thing can be converted to function. I don't know why I thought that having a hash define would be much better. Nevertheless, yeah, I think let me do a function which is much in a neater way, right? So let this return a void, and let this be the function create node. I can, yeah, let it be in capital, or we can actually make it small caps because it will get easily confused with head is a pointer, last is a pointer, and new also is a pointer, right? And let me copy the same stuff actually from here, and I'll get rid of the backspaces, unnecessary backspaces, which are not required in function call actually. Yeah, this does make sense. A small typo there. Size of struct. Okay, this makes sense. Then once this is done, this is fine. I'll assume that malloc is always successful in this case. That is a reasonable assumption we could do. And we just return here. Okay, let me get rid of all these things. For new node I need not pass, right, because I can have it as a local variable and use it here, right? Therefore that's one more thing, because there is no point of new after that, right? Therefore let me just have it here, right? And I think these have to be double pointers now, because I'm going to modify, otherwise it will get only locally modified, right? Yeah, I think that was another reason why I think I might have thought of having it as a hash define, possibly in my head. Yeah. It would still work. Yeah, the priority for star I think is higher. Yeah, okay, this is turning out to be interesting now. So I have to call a create node here, and I'll pass a head, I'll pass last, and I have to pass the value actually, right? Therefore let r be the value. Therefore now I have to take r as one of the inputs, right? Here int r. Okay, and yeah, new of value is r. This is wonderful. Yeah, this is exactly what I thought of having, right? Okay, now once I reach the end of it, right, now what will happen is, now say one of them remains. Okay, I don't know whether L1 or L2, one of them will be a non-null. Okay, therefore let's think of that. Okay, say if L1 equal to null, it means that now I need to parse L2, right? and if L1 is not equal to null, then it means that I have to still go through L1, right? This is the ternary condition, right? Therefore let me call this as a temporary header from which actually I have to find this, right? Therefore this is a return type that I want. Therefore temp will point to either the end of L1 or a L2 once the while loop is done. Okay, then I will create one more while loop, right? Exactly like this. Let me copy the same while loop after this, but here I don't want to go through L1 and L2. I just want to go through temp, whatever is remaining, and I want to add sum of only temp and same thing, right? And only temp will go next. There is no L1 and L2 here, right? Either L1 or L2, one of them will be here, right? And this is same thing, head and last and whatever our idea was there, right? It will be the same thing. Therefore I had another question. I think here we have to pass the address of head and address of last, because that is going to get modified. I think this is another thing I didn't think of then. Okay, yeah, this looks good. And it's possible that once this while loop is done, there might be some still remaining, right? Which is a carry forward. In that case I have to still create that. Therefore if sum is a non-zero number, right, then also I create this none, right? And this time I pass sum. Therefore this is my node and I return head back, and I think that head will get eventually freed up in the column. Okay, this is my function, which I think will solve the problem. Let me write the driver function also for this, right, quickly. Therefore maybe very simple driver function let me write. Therefore let me create two nodes and add them and see what happens, right? That is the simplest thing I can do. Or maybe, okay, let's see. Say A is one of the node and B is another node, and I want to add A and B together. Let's assume that. Okay, therefore A dot value is say 3, and A dot next is of course null because I don't want anything, and B dot value is say let me have interesting thing, right, 9, so that the addition is larger, and let me try to see if that works. Null. Okay, now I have to get the result, right? Result will be in a pointer which I am supposed to free actually. Therefore say this is my result, right? Therefore result is equal to whatever this function is there, right? Add two nums, we have to call that and pass those. Add two numbers and I have to pass the address, and oh, I have to print the result actually. Printf sum of two number is, okay, let me write a small function actually to print the void print list or something like that, and say it takes struct HarishNote star p. Okay, and it's very simple, right? While p, it will printf the value %d of p, and say just like notation of linked list, I also do this p of value, and once everything is done I'll printf null and then \n, and let me call this over here, print list of the result, and let me return 0 here. Therefore, let me go to the GCC, add two numbers. Yeah, lot of values doesn't have value. Oh, sorry about that. Therefore, it was val all the way. I think I've done a lot of places. Let me just replace all the places where it is there. Value to val. Okay, error null is not defined. Oh, I have to start including, right? Because hash define, hash include stdio.io.h and hash include stdlib.h. Temp is undeclared. Okay, I think I forgot to do that over here. Where is R? Okay, let me. Okay, last is a point. Okay, this I think I have to. Yeah, eventually solve this. I think there are braces necessary there, otherwise it won't work. Yep, that does make sense actually. Did that go? Yes. Reminder is undefined. Oh wow, okay. Okay, R is supposed to be reminder then. My mistake. As well as here. Okay. Hopefully it doesn't crash. Oh, it's printing 2 forever. Okay, this is again my mistake. I didn't move the pointer P of next. Yeah, 2 1 null. Therefore, let's go back. What were our numbers in the driver function? It was 3 and 9. Yeah, I think it does make sense. 12. Yeah, if you read it the reverse way. Okay, let's now copy this and try to submit it and see what happens. Therefore, the print list is not required. Therefore, let me copy from create node till this. Okay, let's paste it here. Let's run the code once. Okay, it's accepted. Let's submit it. Okay, it's 87% better than other online submissions. Yeah, I think this is okay solution. Yeah, thank you.